Welcome everyone. I'm Professor Ma from the Department of Computer Science at Tsinghua University. I'm very glad to see everyone here. So let's enjoy the beauty of combinatorics together. Here in the Department of Computer Science at Tsinghua University, combinatorics is a fundamental course set at the graduate level. But then we might ask, since we have taken so many math courses throughout our education, why do we have yet another math course at the graduate level? We might not have heard of combinatorics before, so if we want to find out what it is, let's go online to have a look. We can find the entry for combinatorics on Wikipedia. The definition on Wikipedia is as follows. Combinatorics is a branch of mathematics. Right, so it's a branch of math that deals with problem of ordering and combining in discrete math, in particular method of counting. In fact, the main application of combinatorics is for counting. So what will we study? Ordering and combining problem for discrete math. So we might then wonder, if we already studied undergraduate discrete math, will we have already covered everything to do with combinatorics? We can have a look at a popular textbook. Take this popular textbook on discrete math. Let's take a look at what it contains. We flip over to the contents page and discover that there are 10 whole chapters. Only in chapter 8 do we find some basics of combinatorial analysis, in which there are a few simple counting algorithms and introductory concepts regarding permutations and combinations. So we see that in discrete math, we only come across very rudimentary combinatorics definitions. In this class, however, we shall really delve into combinatorics and related fields, not least the familiar concepts such as permutations and combinations. We shall pay particular attention to recurrence relations with wide-ranging applications in computing. We also cover the inclusion, exclusion, and the pigeonhole principle. Finally, we shall investigate the very interesting topic of counting the colors of polygons using Burnside lemma and polyak counting. We can therefore see that combinatorics will involve in-depth study of counting algorithm of discrete objects. Next, we shall take a brief overview of the history of mathematics. Let's start from this graph. What does the first illustration depict? This is in fact a calculating tool used by the people of the ancient Inca Empire. We can see that the mathematics has roots in counting. Then, after grasping the fundamental concept of counting, we began to develop arithmetics, elementary algebra, geometry, etc. Until the appearance of variables in the 17th century, mathematics moved into virgin territory and thus began advanced mathematics, linear algebra, probability, etc. These topics are so-called mathematical analysis, whose fertile grounds has produced Leibniz, Euler, Gauss, etc. Later, we discovered that the mathematical analysis alone is insufficient. So upon the foundation of mathematical analysis, we developed topology, abstract algebra, group theory, set theory, number theory, etc. These form the basis of modern mathematics. With the development of computers, people gradually found that the combinatorics has become a very important branch of modern mathematics, for it directly impacts upon the theoretical development of informatics. From our view of the development of mathematics, we discovered that the general development of mathematics mirrors our own mathematical education. There are many parallels to our personal experience with mathematics. Then we were young, we began counting from 1 to 3. During the secondary education, we already learned arithmetic and began studying algebra and geometry. Upon entering university, we first encountered formal mathematical analysis. We study advanced mathematics, investigate linear algebra, etc. But for modern mathematics, we require more specialized tools and techniques. For example, we learn about graph theory and topology. Combinatorics is especially relevant for computing and form parts of the theoretical backbone for computer science. Only after detailed study can we hope to gain a more thorough understanding of algorithm. To paraphrase the celebrated combinatorialist Brody, what is combinatorics really concerned with? It investigates things about obey to some degree a rule or pattern. Then we ask ourselves, under such a rule, do they exist? How many distinct forms can they be? Can the algorithm be improved in combinatorics? Then we aim to answer three major questions. First, the question of existence. Second, the question of counting. Third, the question of optimization. Since we now understand exactly what combinatorics is, we shall in the next lesson explore in depth the origin of combinatorics.